Hello guys, so let's discuss today's POTD of Leetcode. So it is a 3349 question which says the adjacent increasing subarrays detection 1. So it marked as easy question. Let's understand the question. Given an array nums of n integers and an integer k, determine whether there exist two adjacent subarrays of length k such that both subarrays are strictly increasing. So we have to focus on this strictly increasing part. Especially check if there are two subarrays starting at indices a and b where a is less than b, where both subarrays are belongs to a plus k minus 1 and b to b plus k minus 1 are strictly increasing. The subarrays must be adjacent, means just the current subarray and the first subarray and the second subarray are neighbors, should be neighbors. Return true if it is possible to find two such subarrays, otherwise false. So let's understand with this example. So this example we have to find the length of three subarrays of length 3, and the subarrays should be adjacent. So 257 is strictly increasing, but 892 is not strictly increasing, so this can't be our subarray. Same for 578 and 92, it's decreasing. 789 and now 789 is strictly increasing, and 234 is also strictly increasing. So what we have to understand through the problem is that the two subarrays combinedly might not be the strictly increasing, but if we see those two subarrays differently, then they should be strictly increasing. Means this should not be like this 7 8 9 10 11 12. This should not mandatory, means the two subarrays among themselves should be strictly increasing. So this is the question, and the constraint are less, so num_stock length is less than equal to 100. Let's move to the coding part. So the brute force, we will solve it through the brute force because the constraints are less. So the first approach will be our brute force approach. So I've declared n variable which holds the length of the array, and I've created a for loop. At the first side, I have traversed through the whole array. This condition, I have realized that the I will always be less than equal to n minus 2 into k if there exists any valid subarray, and it is obvious. Why? Because we have to find the length of two subarrays of 3 length. Means we have to find two subarrays of 3 length each, means 3 into 3 6. So it should be, I should be always be less than here, means we have to check the last subarray we can check is this, because the length is 6. So last subarrays we can check for these two subarrays. So that's why the I will be till n minus 2 into k, and I have used the check variable to check whether I have find the first increasing subarray or not. So I am just creating a loop from I to I plus k, means this 3 length I am finding this 3 length subarray from this loop, and if at any point my previous and the current my previous element is greater than the current element, then it means this is not a valid subarray. So I have then the check variable to 0. I have marked the check variable to 0, means this I haven't find the valid subarray. So if the check variable is 1, means I have find the one valid subarray, then I'm just traversing from the next to the current subarray till the length, till the kth length. So here also I'm doing the same as above, and if if I am not able to find any subarray, or at any point if the previous element is greater than the current element, then I marked my variable to 0, and if the check variable is 1, then I have found my subarray. So I am returning true, otherwise false. So the time complexity for this approach will be approximately order of n here, and I'm creating these two are independent loops. So order of n this will take, and order of n plus order of n this can take approximately. So the overall time complexity approximately will be order of n square, and I'm not using any extra space, so the space complexity will be order of 1. Yeah, this is the approach that came in my mind. So thank you for this.